Shit, nobody. That guy, no. Um, the good news is everybody will be able to be able to print in space really soon through us. We're opening up our 3D printer so people, makers like you, can send parts to space digitally, essentially emailing your hardware to space. Very game-changing, very exciting. It used to take teams of dozens of rocket engineers just to figure out how to get hardware to space. Now you can print it on demand within hours to days rather than months to years that most space missions take. So I'm gonna talk a lot about Made in Space, but I'm gonna want 3 key takeaways that I want everybody here to remember. First, 3D printer is going to space this fall. You can use it this year. You can email your hardware to space, and more importantly, this turns into something really big, a future where people can actually go to space, live on the moon, Mars, do real space exploration. We're limited right now due to the launch vehicles what we have today, and that's what this leads to. All right, so we'll talk a little bit how Made in Space started. Started with a really, really big vision. I personally wanted to help, make humans a multiplanetary species. For the more bold of you, I wanted to help colonize the solar system. This is really, a little bit crazy talk, but I realized that the technology is growing rapidly at rapid pace. A lot of you guys know about Moore's law, and with the right focus and the right groups of people, you can make this happen. So I put up a picture right here of the pale blue dot and Carl Sagan's quote, just as a reminder of how small we really are and how big we can become. So the picture on the right is, you can see a little further out of Saturn's rings. You can actually zoom in. The picture on the left, where the arrow is, you can see a pale blue dot. And Carl Sagan is here saying, this is where everyone who has ever lived in the history of man has been on this pale blue dot, and everyone who will ever die has been on this pale blue dot, unless we decide to go further and further out into the solar system. So that's how we started. That was the motivation. So I started going around to space conferences, meetings with many of my co-founders. I went to Singularity University in 2010, which focuses on exponential technologies. I met 3-time astronaut Dan Barry, a lot of other people in the space industry. We decided to co-found this company together with this goal and with this vision. We started really thinking about, all right, if we want to become a multiplanetary species, this again crazy, far out there goal, what do we got to do to make it happen? We realized, space has a supply chain problem. You have really, really expensive transportation vehicles. These things cost tens of millions, often hundreds of millions of dollars. Lots and lots of zeros. You have to travel a lot of distances, taking months to years. Half a year to get to our closest neighbor on a good day, Mars. So this leads to a lot of risk, and it's very, very time-consuming. And out here in Silicon Valley, we know that time is not something that we like. We like to innovate quick, rapidly iterate, and all these problems with space inhibits innovation. So what most people do is they come up, they're like, all right, what we need now is faster rockets. Because faster, cheaper rockets, cheap access to space is what will really change the space game. And it reminds me of a quote. My CTO, Jason Dunny, actually points to this quote actually from Henry Ford. If I would have asked people what they wanted, they would have said, bigger and faster horses. Of course, he wouldn't have made, mass-produced the car. And it's really the same thing. People think they want cheaper and faster rockets, but what they really want is just the hardware they want on demand when they need it. And that's when we realized that the solution was 3D printing. So this was in 2010. Early makers really knew about 3D printing, but if you would have went to a room of like 100 people, asked them, hey, raise your hand if you know what 3D printing is, maybe one person would have said me, maybe 2 or 3, depending on the audience. So we were really like a little bit ahead of the curve there. We realized that 3D printing is changing how you get things from point A to point B. So the way goods are generally manufactured today in America is they're, actually manufactured generally in another country. Then they're put on a crate, that crate's then put on a ship. The ship then shipped halfway arown the world. Crate's then taken off the ship, put on a truck's then taken to a warehouse. Crate's then taken off, put down into smaller boxes and shipped again, over and over. And this is what 3D printing really has the capability to disrupt, supply chains like that. And in space, the supply chain is even bigger. You have to account for rockets in the equation. So when you start building what you need on demand, things start to change. We're already seeing 3D printing changing many things down here on Earth. You guys know about a lot of this stuff. Things from guns to rocket nozzles We're even doing 3D printed houses. They have a big initiative in China where they're 3D printed hundreds of houses now. Imagine in a third world country, if you don't have to have an entire construction crew, you just put a printer, you use the materials off the land, and actually print a house. This is what we're moving towards. It's going to change economics and manufacturing here on the planet, but it's also going to change it in space. And that's really what we started with, one goal: bring manufacturing to space. So if you want to go to Mars, you build a house on Mars using Martian material. You don't bring everything you need with you because that's nearly impossible. The Moon, the International Space Station, this is what we're changing now. So we started the company in 2010 with that goal. We really spent that year learning about the technology, kind of mastering it. In 2011, we took it to the skies. So we got our first NASA contract that year. We've had over $1 million worth of zero-gravity flights, where you're essentially flying in a parabolic aircraft, and the plane is like nearly tilted up. Pretty scary experience. The plane's nearly tilted up, for about 30 seconds. Then it tilts down as if it's going to crash into the ground, and then last minute they pull back up again. And they do this over and over and over. And during the parabolic arcs, you get about 20 to 30 seconds of microgravity. You're floating. One of the best experiences ever. We've sent a lot of our guys, to zero gravity, about 24 now. And it's a really, really good, interesting experience. We also did Martian gravity testing, gravity testing, about 5 hours total, and 500 parabolas, 500 of those arcs. So we started zero gravity testing with the goal of bringing an off-the-shelf printer. Many of you guys know, some of these printers you can tilt upside down, they work fairly well. Outside it works fairly well. We thought that there's a big chance that it would work in zero gravity, but none of these off-the-shelf printers actually did. So we really learned that we had to build a custom printer, made specifically for zero gravity. So that's what we ended up doing over several flights. That's what we did during 2012. So you can see the column on the left. You can see issues during the layering during the zero gravity phase. The column on the right, the layers are exactly how we designed for them. So that's really through these flights we were learning how to make a printer work in microgravity. We also had a lot of fun. Here's me spinning. Why they call it the vomit comet. I did not throw up though. Only one of our guys spit it up. He likes to claim I didn't throw up. He says I spit it up. It's really interesting on these microgravity aircraft. They call it the vomit comet because people throw up, and usually it's just one or two people. But then there's a chain reaction is what ends up happening. You start smelling it. Oh god! It's like it's in our nature to throw up when somebody else throws up because something might have been bad in the food that was eaten. And so after we tackled the gravity problem, there's a multitude of other problems that had to be tackled for building a 3D printer for space. Basically, these astronauts are in a enclosed environment, and any type of materials that could harm them are very bad. So you got to environmentally control the printer, especially when you're melting polymers. There's some of the ABS, things like that. There's been studies that show it could be harmful to the crew in such a tight space. We had to figure that issue out. We had to ruggedize it for launch, probably the most ruggedized 3D printer out there. We had to make sure it was ready in mission-critical situations. The astronauts need to be able to count on it when something happens. So after we built this printer last year, we then took it to NASA so they could test it. They vibrated it around and make sure nothing falls out, and do various other tests. What we really learned, something that really opened my mind and helped me understand even more what we're trying to do, was that the printer was ready to go 18 months before launch. We built the thing in 6 months. They had to wait another 18 months because of all of the supply chain issues I was telling you about in space. And that's when I realized we are really, really going to make an impact. Because if somebody wants to send something to space, we've already had dozens of companies, one-man entrepreneurs come to us, lining up, ready when this printer's up there. They're like, man, we'll just skip all of that. We'll just, literally email the file up to the space station. Made in Space will print it, and I have my product up there. That's what we're trying to do. That's where the game changing comes in. All right. So after we tested, we also simulated as if we're an astronaut. Basically, this first printer, what the astronauts have to do is they have to stick their hand through these holes and essentially make sure that they're not flipping over their head as they're using the printer, so they stick their feet in these straps, and they operate it as they would down here on the ground. We've tried to make it as simple as possible for them. And then this year, it's going to be going to the space station. As I said, it's a big moment because it's the first time we've ever built tools or parts off of planet Earth. But the astronauts are more excited because it's the first time they get an upgrade over the duct tape that they've been using for all these years. Anytime they've had a problem, that's all they had. All right, where's the duct tape? We got lots and lots of duct tape. So we're going to take it from Houston, we have a problem, to Houston, we have a solution. Most people know about the Apollo 13 problem. There's too much CO2 rising in the module. And what they ended up having to do is they had a couple dozen of the brightest engineers in NASA. They called them their A-team. They pulled them into a room and like, all right, the astronauts are going to die. This is really big in the news. And everybody was kind of watching, and they're like, all right, we need to solve this problem. And they did. In about 24 hours, they were able to come up with a solution, taking everything that they had, from the parts on the space station, to mock together, something to put the round peg in the square hole, type thing that they had to take care of. So it was really interesting because we started looking at this problem. If we had a 3D printer on board, what would you do? So just for fun, we put an intern on it who hadn't even graduated college yet. We said, all right, design something. So in under an hour, he had a design ready, and in a couple hours, he had it printed. So that's the difference between 3D printing and not 3D printing if something goes wrong in space. Our onboard astronaut Dan Perry likes to say, 3D printer is going to be really, really useful for the space station. It's going to be absolutely necessary if we ever really want to go to Mars. I completely believe it.
You found the coffee.
So there's many parts that we use today that you can build even with these polymer-based 3D printers. For the best designers out there, that you can really 3D print most things. You can really stick your mind to it. So things from like standard hardware to experiments. We like to call them massless experiments instead of no mass.
Okay.
Email the hardware.
Relax.
Tools and spare parts, emergency fixes.
If we see that, we should ask
things,
them.
To build in space when you get to the point where you're building spacecraft.
Like the map.
Stuff like that as well.
Where are the crates?
I want you guys to really think about this. Like, what could you build with a 3D printer on the space station?
You said they're way down in the corner.
We did this for. It's a platform.
Who knows
similar to how your iPhone is a platform for anybody that wants to develop
down in the
apps,
corner all the way at the end.
games, things like that. Same thing for anybody who wants to design hardware for space, whether it's to do an experiment in a space environment, whether it's to help make the astronauts' lives better, or whether it's to do some type of test to help push space exploration further. These are the things that you can do with a 3D printer on the space station. And all of this is a building block towards the future. So we're building off of the ISS to really go to Moon, Mars. We've used our printer technology to actually build with regolith.
It looks good finally. That's coming through the internet back down
as well. So you don't have to take the material with you. You just get the materials in situ, is what they like to say in the space industry.
And if we had it slides, we do it on this one. So anyone who slides, we can
really build our future there using the material there. That's where this is going. It's going towards large populations of people in space. This is why we got so many people excited at Made in Space working on this.
It might actually
I really want to invite you guys, to come 3D print
scenario.
Contact me. That's my email. If you have any ideas,
for the
let me know.
shooting the slides, but I was alone, so. Yeah. No, don't be sorry. Dude, everything you do is awesome. It's great.
Any questions? This guy's hand went up first.
Here, I'll show this for a second in case people want to write it.
So did they put any restrictions on the materials we could use for feedstock? Actually, yeah, ABS.
Could you read it?
They don't want ABS. They're like, which is the most commonly used material with these 3D printers. The first printer is using some ABS, but essentially, they did some off-gas testing that when it prints and over a certain amount, and NASA's a little too careful anyways, but over a certain amount it might harm the
like this because we got camera
radiation up there all the time. Yeah. Anybody else? I saw a few hands.
Except for when he moves. I wish we had a better head. I wonder if they have other tripods back there.
Is that art? Is that your tripod?
That one, no. And that one's kind of too.
So he's asking about using the vacuum of space to print with metals. Is anybody looking at that? We are. It's definitely you want to use the advantages you have in space as much as possible. That is one of them. With printing the vacuum of space, you also have to control for other things like there's thermal issues. You go from really hot to really cold. But we're definitely looking at it. You can start building interesting things when you build in the vacuum of space as well. Cool. I see a hand over here.
Okay, maybe wider than he's gonna run around.
So we printed with regolith. This guy right here behind you has something to do with it. Comes in on the weekends.
Cutting to you.
And chips in made in space. But yeah, so you can see this little brick right here. The bottom right is a brick that we built using JSC1A. It's a type of regolith that's basically very similar to the regolith they have on the moon. This is something we're really excited about because when you start building out of material on the moon, I think that's when people will start opening their minds a little bit more. When NASA themselves it's great. We work with a lot of groups inside NASA, but you also have some people that have been there for a really long time, and they still don't see the disruption of this technology yet. But I think once we actually build, brick or even a little doghouse, on the moon out of material there, that's when you can see a lot of money, filter from our space program into this. Cool. All right, this guy right here. All right, it's a really good question. Where does the power come from to power the 3D printer? Magic. No, I'm kidding. So what they have is they have solar panels on the International Space Station. It's like a football field long or something. Largest panels that we have in space. And that's used to power everything that the space station does, whether it's flushing the toilets or getting clean water or 3D printing on the station.
The next guy slides?
Cool.
No,
This guy too.
We got 9 minutes. Oh, it should be sticking out a computer.
Have we say it again?
Printed wood or glass?
Oh, did you get it back?
We have not 3D printed wood. We've dealt with the optics a little bit, but the wood 3D printers there's some old ones out there that are like the first 3D printers. Have you ever seen a wooden 3D printer?
I don't see it.
They're a little interesting. It's scary because when you're printing, there's obviously heat involved.
Is it in your pocket?
Yeah, you know how it reacts with heat.
I got something in my
We try to stay away from that. So what's in our initial sets of tools that we want to build? It's a really good question. I mean, obviously the basic ones, like we're going to be building, a wrench, screwdriver, using a little bit of metal stuff, socket wrench up there as well. There's a lot of components on the space station, actually millions. And NASA, what they do is they generally contract out to multiple companies. Boeing is usually one of the biggest companies that has built a lot of this stuff. And a lot of it's like closed. So you really can't see like the list of parts that are up there because it's gone through contractors. What I'm really hoping to do is, again, the reason I'm even here is because I want to inspire people to think about like they could design something that the astronauts would use. And I'm completely fine with them taking a few chunks out of Boeing's check, type thing, and starting and helping enable small businesses. Hey. Oh, that's a really, really good question. Do they have a way to scan something that's broken if they need to print something? So, yeah, we're not only setting up a 3D printer, we have a contract to set up 3D scanner.
So there's like there's a whole folder of like.
So that one, I don't think I'm allowed to publicly say whose scanner we're sending up, but we're partnered with a really good scanning company to send the scanner up. And so it's really twofold. It's one to scan something if it's broken and they need to print it, but it's also to scan something after it's printed to make sure that you actually printed what you wanted to. I mean, anybody that's dealt with 3D printing a little while understands that sometimes these prints don't come out as expected. All right. Hey. Okay. If we print something, wouldn't it float away? Well, yeah, it could. So that's one of the problems that we had to solve is adhesion to the print tray. It's actually one of the first challenges that we had to solve because in microgravity things float. But we were able to take care of that to make sure that it sticks to the front tray. All right.
Who's the main?
It's a really good political question about Russia. And so, as he said, Russia is pretty much saying they're going to revoke our access using their rockets. They're also so Boeing and Lockheed, the two big companies, they buy engines from Russia for the rockets they use. So thankfully, we have a few other companies like SpaceX. We'd be in a lot of trouble right now. We also got some partnerships with some the Europeans. They also ferry back and forth to the International Space Station. We're going to be able to send our material up through them, and it would definitely be an issue if it wasn't for that. SpaceX is now trying to say that they're going to fly humans, men and women, up to the space station, so that doesn't have to rely on the Russians anymore. So hopefully that'll happen. The good news is for us is we will be able to 3D print some hardware there. And if we'll have stocks of material, assuming that doesn't run out, we'll be okay. Other good news is we also, this contract that just became public, we also have a recycler. So we need to recycle some of the waste on the space station, turn it into feedstock, good. Or if we need to recycle printed parts that aren't needed anymore, we'll be good. So really, this definitely has the capability to help kind of soften that blow a little bit. That guy? Okay.
Like, wow. You can just put the slide. It's really good. It's up to you. Whatever. Give it all folder.
Yeah, so he's asking about printing with like metal or regular. Like what are the challenges? So obviously, with metal, that's liquid in there. So obviously, with metal, liquids can become a problem. Powders can definitely become a problem. We don't want powders floating away in zero gravity. You definitely don't want that inside the space station. So I mean, those are some challenges that have to be solved. Printing with this regolith, there's a lot of interesting ways you can do that, especially with biocomposites. You have a little bit of gravity, so the gravity challenge isn't as big. The main issue with metals, though, is just power. It takes a lot of power to really,
I don't know. It'd be too hard to work on that there.
Yeah.
Put that one up on the
Sure.
Say that again?
That's a good idea. Okay.
Well, there's dozens, maybe even 100 now, different like metal additive manufacturing technologies. But yeah, all of them it comes down to power, so you can heat the material enough so you can bond the material together. Okay, these two have had their hands up for a long time. I'll go ahead first, then you.
Oh.
Because it has to be next. That cable's so short.
Okay.
Assembly, maybe some parts that need what's your relationship with scientists that are out there? You have a program that describe the assembly so that they can see a whole data together a big telescope.
This is a really good question. Again, those of you that use 3D printers know that that's only like step one. Step two is you got to kind of assemble the part that you built with whatever you want to use it for. So it's asking, how are you going to get the astronauts to actually do that? So luckily, we have a really good relationship with NASA right now. They've divvied up some crew time for us. So the crew is going to be assembling stuff on the space station, for us. They also are really excited about this, project. And so they have a lot of experiments going to the space station, and so really too much for them to handle, like during their main hours. But a lot of times they spend time on their off hours because it's funny, it costs millions of dollars to get them there, but they only work like 8 hours a day, scheduled. But so their off time, they also are doing usually work, especially on the projects they like. And so we've been told that they really love this. I mean, it's kind of an astronaut sidekick if you think about it. They need something, here you go, build it. So they like this, and we really think that they'll make sure there's time to make it happen.
You mentioned not being able to print ABS inside the space station, but what I'm curious about is, do you have a polymer that you can print and then use outside of the pressurized environment?
Yeah. So, is there polymers outside the space station that you could use? And the answer is yes. So it's definitely something that we're working on. We're going to be implementing with our second printer. I don't think I said this, but we have a second printer that's going up next year, and that's really it's like more what we're calling this first printer's a demonstration, technology demonstration. The next one's really the one that's churning out parts left and right. And that the idea is that you could have parts that could go outside the space station. Cool. All right. And then yeah.
Are you limited to simple mechanical components, or could you say silicon made electric?
Can we print electrical components yet? Um, so the the answer is like twofold. First printer is not going to be able to print electrical components, but definitely very near on the horizon where we can. I mean, depending on how much you're looking in the industry, it's like some people are doing that now, modifying even these off-the-shelf printers. So it's something that we're looking at. The question is, when can it get to a usable enough state? The idea that we're working on is, again, because we want to open up the paradigm for everybody to use, is having some type of electrical components and sensors up there that if people need it, they can integrate it with printing in some way. There you go.
So when do you think you'll get to the point where you ship a print head, some motors, and print the rest?
When do we get to the point where we ship some print heads and motors, and then we just print the rest? So when are we printing printers out of printers on the space station? It's a really interesting question. The first part that we're actually printing is a part of the printer itself, just as a kind of for some fun. Obviously, these printers can't print all of it yet. I think the rep wrap, and some say they said like 70% of it could be reprinted. I think it's not too far off there. I mean, it's definitely I think within a 10-year time frame where that's really possible. So yeah, cool. You sir.
3D printed object in plastic, would it deteriorate without space?
I like the hat. So if we 3D print an object in plastic, won't it deteriorate once we go out in space? There we go. Yeah, yeah. So it really ties into the question that he was asking there. And as I said, I mean, this is like, obviously one of the things we're most interested in if we ever want to use, parts outside the space station. So our second printer, we're already doing material development, where we're looking at materials that could, work outside in the vacuum of space that you could also print. There's a few challenges there, but a lot of them have been solved by others that we're working with groups. Things like Ultim, Peak. These materials are really close to materials that could be used out in the vacuum of space. Good to see you. All right. You. Can a printer be used to make repairs to a spacecraft? I hope so. I mean, yeah, technically it's possible. Now there might be obvious challenges, from political hurdles to it not being done that often before. But it is what we're trying to get to, where you're actually repairing it. You ever seen like Hubble 3D when they had to go up there and repair? Imagine if you just were able to print it, repair it, and get it done within weeks, and not have to build like a year and a half long mission around that. All right.
Is there some symbolic piece that you're going to make as your sort of first real printed in space?
Is there some symbolic piece that we're going to make for our first real 3D printed in space thing? Hey, this was a really big challenge within the company. I think they might be kicking me off soon, but was a really big challenge within the company because I really wanted a symbolic piece. We thought about it for months. We did brainstorm sessions, and everybody's arguing back and forth. I want a pyramid because pyramids are cool. I want the Made in Space logo, or I want some infinity symbol because this symbolizes people going out into space forever. It was really interesting. Nobody agreed on anything. And, like we really realized symbolism, really bad at that word. It's really it's up to the person really what they feel is symbolic. So what we ended up just deciding on was that just the printer would print a piece of itself, with the Made in Space kind of logo on it. It's our best cut at that. But if you have any other ideas, I mean, it's still not too late to change that, and we could even credit you as the the thinker behind the symbolic piece that goes to the space station. All right, I think we are done. Thank you guys. It was really good talking to you. Keep making stuff. And again, oh, they took my slides off. Aaron at maidenspace.us. Shoot me an email if you want to make things in space.